All right, I want to focus on one specific problem because it is the sort of thing that is going to pop up later. And also because there's a very interesting result that comes out of it that is kind of unexpected. So what I want to do is I want to simplify the expression cosine of arctangent of x. So this is a composition of a trigonometric function and an inverse trigonometric function. Now, if we think about arctangent of x, what that means for us is what angle gives us a tangent that's equal to x. And we can use right triangle trigonometry here to figure that out. So here is a right triangle. And let's say that this angle is theta. And we want theta to be the angle that is arctangent of x, meaning that the tangent of theta equals x. All right, so actually we can even write in here, we can write in theta here equals arctangent of x. And what that means is that tangent of theta equals x. And of course we can write x as x over 1. And it's helpful to write that as a ratio because we know in right triangle trigonometry, the trigonometric functions are ratios. Tangent is opposite over adjacent, so we could label this x, and we could label that side 1, and this drawing matches this relationship, right? Tangent of theta is x over 1, which is just x. So that means that theta is arctangent of x, or x over 1. And the reason that we do this is because if we want to know cosine of arctangent of x, remember theta is arctangent of x, so all we really need to do is find cosine of this angle theta. But we know that cosine is adjacent over hypotenuse. We know the adjacent side is 1. If we can just find the hypotenuse, we've got our cosine. And the way that we can find that hypotenuse is by using the Pythagorean theorem, which says in a right triangle, a squared plus b squared equals c squared, where c is the hypotenuse. In this case, the sides, the legs of the triangle, are 1 and x. So we can say 1 squared plus x squared equals that hypotenuse squared. Of course, 1 squared is just 1, so that's the same as 1 plus x squared equals the hypotenuse squared. And to solve for the hypotenuse, we take the square root of both sides, and we end up with the square root of 1 plus x squared for the hypotenuse. And then we know that cosine of an angle is adjacent over hypotenuse. And so that is going to be 1 over the square root of 1 plus x squared. So that means that cosine of arctangent of x is equal to 1 over the square root of 1 plus x squared, which might be a slightly surprising result because on the left-hand side, we have something that is trigonometric and something that's an inverse trig function. But when we take the composition, we end up with something that's algebraic, right? We've got the composition of two transcendental functions, and we end up in the end with an algebraic function, which is a pretty interesting result. And this is going to be a skill that we use later on, finding the composition of a trig function and an inverse trig function. And so we want to be able to get a little bit of practice now with these so that we're comfortable with this skill, because later this is going to be one small part of a larger problem. And we don't want this to be the part that we get stuck on. So please go through, do some example problems, get comfortable with this so that you've got that muscle built for later on when we need it.